Thank you so much for coming back today at our channel, The Physics Mindset. Okay, today we are going to look at the inverters, the problem facing the inverters. The inverters has, you know, the inverter is a man-made device. Okay, now it has some functions. Its function, remember, its function is to bring the DC voltage from the battery, and it converts it into AC electricity, which we use for our appliances to work. The TVs, the appliances which uses AC, alternative current. Okay, the TVs, the lights, the fridges, AC, every gadget which it uses AC, because AC it comes from an inverter. An inverter, its use is to convert DC into AC. Now we're going to look at some of the problems facing an inverter, and then we look at what brings these problems to the inverters, the signs, how you can tell that this problem is this kind of a problem and it is caused by this. We're going to look at all these issues. Then we look at also the solutions, how to solve these problems, because our customers face a lot of this challenge. Okay, we challenge that customers or technicians, electricians install solar system, but to do the repair part is a bit hard because they don't know the problem, how to solve a problem. Now this time round, I'm going to show you how this problem comes out and how you can solve this problem in inverter problems. Okay, now today we're going to look at the inverter problems and their solutions. Let us start with one problem. I'm going to give you 3 problems. As I told you, I give you a problem, but be curious when I'm explaining every solutions, because I give a wide range of solution, whereby if you get a problem under the solutions I've given you, you can still use these solutions to tackle the problem you have faced, even though it is not the problem which I've given you. I'm giving you basic problems which normally face the inverters. Okay, now the explanation I give a wide range of explanation technically, so that you can use even on other problems. Okay, now today we are going to first see the problem 1. Problem 1 is the inverter not turning on. Problems, I'm writing them in red color. Okay, then the solutions, we shall write them in blue. Now the inverter not turning on, this is one of the problems in inverters. The inverter is not turning on. What can be the problem? If your inverter is not turning on, once you switch it on, the inverter doesn't go on. You try to check what can be the problem of an inverter not turning on. If it is a customer, a customer has no idea of the repair part. It is with the technicians. Okay, now a customer is switching on his inverter, but the inverter is not turning on. The inverter not turning on, it is a problem. It is a problem. Don't stress much yourself. Okay, one of the signs you can tell that an inverter is not turning on, that is the problem, you'll see a display remains off. Inverters have displays. Let us say this is our inverter, like this. Okay, inverter has a switch button here which is on and off. You press it, it goes on, then after you can press it to go off. It has a display. Some inverter have display, some inverter don't have display, but some inverter have displays whereby it displays the voltages from the battery, then it displays the output voltage, either it is 220 volts AC. Okay, then it has lights. Some inverters have only lights. Okay, which lights? It has green to show that it is on, red to show that the battery is low, or yellow for a warning. Okay, it has 3 colors: red, green and yellow. Okay, each color has an indication. When you see a red color, just know that that indication is there is a danger or battery is low. Okay, yellow color means a warning. A green color means something is working on well, everything is fine, like green. Okay, now these inverters, some inverters don't have display, some inverters have only those LED lights which give an indication to we technicians. Okay, if I see a red lighting on an inverter, I will know that there is a problem either on the output or inside the inverter, or there is a low battery. If I see a yellow color, I will know that there is a warning. Either the battery is running low or there is overload. Okay, inverter color, those LED lights, they indicate something. Okay, now if you have an inverter and the display you switch on and the display remains off, just a problem of inverter not turning on. It is a problem. Okay, then another sign which you can tell that an inverter is having a problem of turning on, you will not see no AC output. When you're using a pure sine wave inverter, and a pure sine wave inverter, for them they are very good. They don't make noise when they are in operation, or when they are converting their DC into AC. You will not hear anything. Those are pure sine wave inverters. Okay, now you switch on. Some inverter have no lights. Some, I said some. You switch on and you don't see AC output. It can light the lights. The lights can come, the green, the yellow, the red can come, but your gadgets, the TVs, the lights, the fridges, the everything will not light, meaning the inverter is not bringing the output. This is the point. Once the inverter is on, it has shown that it is on, but no AC output. Remember, an inverter converts DC into AC. Now there is no AC, meaning our gadgets are not going to work. Inverter not turning on. The inverter is not switching on. It has components inside it. These components are electronic combined. Those are the resistors, transistors, capacitors. Okay, it uses transistor to switch on. Okay, these are we shall look at these topics when we reach in the electronic parts. Okay, function of electronics part. Okay, now this transistor may fail to switch on the AC, to convert DC into AC, and it is a problem also, which shows us that our inverter is not turning on. A client will say the inverter is not turning on. He will call you, the client will call the technician. He has switched on the inverter is showing, but it is not turning on. Some inverter have no display. Okay, they give only the indication of lights, which is okay. Okay, but no. Now, what are the causes which brings the inverter not turning on? Let us see some of the causes which bring the inverter not turning on. Causes which brings inverter not turning on. The display remains off. No AC output from an inverter, and our things are not working. Let us see the causes which brings up this thing. Number one cause is low battery voltages. Low battery voltages. On batteries, low battery voltages. There is low battery. When the voltage, we expect our solar panel to charge the battery, and at night we expect the inverter to consume power from the battery and it lights our gadgets. But once the battery is low battery, once the battery has low voltages, the inverter will fail. The inverter will fail to switch on. Okay, let us say our inverter is set to be on when the voltages are 11 volts. Okay, now or 10 volts, that those voltages are from the battery. Let us say this is our battery, positive, negative. Now it has 12 volts. 12 volts 12.7 volts connected to our inverter. Once you switch on your inverter, it will work. Now when the voltages go down, low battery voltages, when the voltages go down of the battery, let us say when the voltages go up to 10.5 volts DC, the inverter will switch off itself automatic because of low voltages from the battery. And this is the point. This is one of the cause which makes an inverter not to switch on. Either way, like when the battery didn't charge, and we didn't expect this, and during day comes, the solar panel didn't charge the battery. Okay, either there is a faulty charge controller or faulty solar panel. The battery will remain at 10 volts or 10.5. At night we come on switch on our inverter. The inverter will not switch on or will not turn on, meaning the inverter, the battery is low, and the inverter will not be in position to switch on because of low battery voltages. That is the cause of the inverter not turning on. Another cause of this problem is loose battery cables. Loose battery cables, well explanatory. Once the cables from, these are the cables which goes to the inverter. Once the cables on the battery terminal are loose, okay, meaning the inverter will not get the voltages from the battery because the terminal cables are loose, okay, meaning the inverter has no power source. The power source is the battery, but the cable is loose. The inverter will not turn on. That's why this problem comes in, the inverter not turning on because of loose battery cables. Another cause, on top of these loose battery cables, even the inverter cables itself, you may forget, or a rat can run when you didn't tighten your cables on the battery terminal. Even a rat can play around the battery terminals and it loses it. That's why I advise you use the correct termination of the battery from the inverter to the battery, because an inverter we connect the inverter on a battery direct. Okay, another cause of not turning on, the inverter not turning on, internal inverter fault. Self-explanatory. The inverter itself, remember I told you that an inverter, either a pure sine wave, it is a man-made electronic device. Okay, now expect it anytime it can get fault. Okay, now here the cause of one of the problem of not the inverter turning on is the internal inverter fault. Inside the inverter, it is electronic. Okay, electronic combination of capacitors, resistors, transistors to make an inverter plus a transformer. Okay, now these things also can get faulty. Inverter, internal inverter, inside the inverter, the inside of the inverter can get fault, whereby the fault comes on this electronic board. This is the combination of resistors, transistors, capacitors and transformer to make an inverter. Okay, now these components can get faulty and they need some replacement. Okay, now these are the causes, the signs, as we have seen the sign to tell that our inverter is not turning on. One of the signs is display remains off, or some inverters use lights, LED lights, green, yellow and red. If you don't see them, just know the display, it shows that's the same thing with the display. Those are the lights. When you see those lights and you switch on your inverter and the lights are not coming, just know the inverter is not turning on. No AC output. The inverter can turn on, but it can't manage to produce an AC voltages outside the output. Okay, it's also an inverter not turning on. One of the causes we have seen 3 of them. We have seen the low battery voltages can cause the inverter not turning on. We have seen the loose battery cables on the battery terminal, positive and negative, may be in loose connection and may cause the inverter not turning on. Another cause, we have seen the internal inverter fault. As the inverter is made by man, it is the combination of electronic components, which components are transistors, resistors, cables, and some capacitors, and the transformer may fail or can get faulty. That's why we have said the internal inverter fault, and can cause an inverter not to work. Okay, and these are the signs and the causes. Now we are going to look at the solutions to the inverter not turning on. What can we do to solve this problem, the inverter not turning on? Let us see the solutions, then we can move on to another problem. Now, since we have seen the causes of the inverter not turning on, okay, we are going to see also the solutions. What solution can we use to solve the problem of an inverter not turning on technically? Remember, let me give you an advice to all technicians, all solar technicians, all engineers. Inverter problems always start with the battery. The battery is the main cause because it is the source of power which powers the inverter. You can't do anything, any repair without the battery. Okay, inverter works on a battery. As we said, from DC, it converts from DC to AC. Now, without DC, you can't see AC. Okay, meaning a battery is so crucial and so important. All problems start with the battery. Always test the battery voltages. That's the number 1 point I can give. Let us see solutions to inverter not turning on. Solution number 1 is check the battery voltages first. Check the battery voltages first because it is the source of all problems start with the battery. Before you handle the inside faults, still you need to test using the battery. Check the battery voltages first. That's the number 1 solution you can use to tackle the problems facing an inverter. Solution 2. No, check on top of this, the battery voltages. The inverter works on a certain voltage in certain inverter technologies. Some inverter can work even on 10 volts battery, but 10 volts means the battery is too low. Okay, when the battery is full, the battery, once you measure the battery, this is our battery, positive terminal, negative terminal. This is our battery, this is our inverter. Now, once you measure on the positive terminal and the negative terminal, how many volts do you see? Okay, it will tell you that the battery, once the battery is low, the inverter will not be able to switch on. Okay, that's one of the points. Check the battery voltages. Now, solution number 2, tighten the battery terminals. This is our battery. Tighten the battery terminals. Use the clamps when you're doing the connection on the battery terminal. There are clamps whereby you put your cable, then this clamp has a screw where you can screw to tighten. Don't just tie your cable around the terminal, I mean. Still, that if you round your cable around the terminal, with the time this cable will lose and it will make our inverter not turning on. But we are saying the solution is tighten the battery terminal. Please tighten. Confirm that the battery terminals are firmly tightened. Okay, and our inverter, then you can switch on the inverter and it will work properly with no loose connection. Another solution which we can see to solve the problem of not turning on, another solution is the inspect inverter protection fuses. Inspect inverter protection fuses. Remember, inside the inverter, we said an inverter is a man-made device, an electronic device which converts DC into AC. Okay, now it has fuses inside for protection. Okay, it has fuses inside for protection. Now check these fuses. That's why they are telling us inspect the inverter protection fuses. Even behind an inverter there is a fuse whereby you can check that fuse if it is still connecting. Check, test it in continuity or if it is blown. Okay, fuse is so important on an inverter to protect an inverter from getting faulty. Check the fuses. If the fuses are fine or if they are blown, replace the fuses and the inverter will work well. Once the fuses have blown, just know that there was an overload and the inverter has protected itself with the fuse blow to protect the circuit of the inverter. And the fuses are so important to check, and these are one of the causes which we can use to check or to solve the inverter not turning on. Cause number one was check the battery first, check the battery voltages first. The solution number two, tighten the battery terminals. Okay, solution number three, inspect the inverter protection fuses. Inspect the fuses of an inverter, then you can switch it on again and test if it is working, and it will work. Okay, now let us see the problem number two. I told you I'm going to give you 3 types of problems in session 1. Okay, let us see the problem number 2, how we can tackle it. Since we have tackled the inverter not turning on, these are the solutions. Check the battery voltages, tighten the battery terminals, inspect the inverter protection fuses, and we shall see our inverter working. Let us see a problem number 2 which our customers are facing, even as the technicians, after installing our solar systems. Let us see the problem and we solve the problem. The problem number 2, we are going to see the problem number 2 which is facing the inverter problems, and we see also the solutions, because we can't just discuss about the problem and we leave the solution. Our point is to solve the problems, okay, of solar system components. And today we have seen the number 1 problem, which is inverter not turning on. Now number 2 problem is inverter overload. Inverter overload, what do they mean by inverter overload? Inverter overload mean, as you see it sounds, inverter is overloaded. Overloaded mean, since we calculated our appliances, I mean the TVs, the lights, the fridges, and we came up that our appliances have 2000, or let us say 2000 watts. Okay, all our appliances use 2000 watts. I'm giving an example. Or either let us say, now let us finish this. If our appliances, we have calculated the watts of the TV, the watts of the bulbs, the watts of the fridge, the watts of all gadgets in the house, and we came up that all our appliances uses 2000 watts, okay, in total. Now an inverter which is supposed to light, to drive this 2000 watt, must be higher than this wattage of the appliances, of the total appliances. Meaning our inverter, we can use an inverter of 3000 watts, okay, which is the same as 3 kilowatt, because it is in thousand. K is in thousand. Let us give an example. If our appliances, the total appliances, total wattage of our appliances, the TVs, the lights, the fridges, and so on, is totaling to 500 watts. What is the inverter which can drive this 500 watt? We can use something like from 750 and above. Let me say, I will give a 1000 watt or 1k watt. 1 kilowatt, and this inverter will drive these loads properly. Now if it comes to inverter overloading, if you overload an inverter, you see, I've given you an example that you give the inverter a higher wattage than the total appliance wattage. Now if you want to see the overload, okay, if it is overloading an inverter, it is like this. If your total wattage of the appliances is 500 watts, 500 watts, you have calculated the total watt of a TV, total watt of a fridge, total watt of your bulb, and you get this 500 watts. Now if you overload, if the inverter is overloaded, meaning you have undersized the inverter, meaning on your total appliance wattage, you're going to get an inverter of 450 watts. That is, you're going to overload an inverter by 50 wattage. If you get an inverter of 300 watts, yet this is the total load, this is an inverter, the total load is 500, and you're buying an inverter of 300, meaning you're going to overload an inverter by 200 watt. Okay, the total load of our appliances are 500. You buy an inverter of 300, meaning you are overloading an inverter by 200. The difference, okay, that difference on top of an inverter which it can't carry, it is what we call inverter overload. And the signs, the inverter will complain. How does an inverter complains when it sees an overload? Because you are putting, it's like a human being. You, if they give you one plate of food, you can eat it. They give you another plate, you can eat it. The third place, you can eat it. The fourth plate, you can eat. The fifth plate, you will complain. How do you complain? They will take you to the hospital. You will not have space for breathing. And how does an inverter complains? An inverter will alarm. This is the sign which will show that an inverter is overloaded. An alarm sound will beep. Okay, an inverter, since some inverter have no sound beeps, but some inverter, for protection purpose or overload purpose, an alarm will switch on. An inverter will switch on an alarm, okay, so that you will switch off some loads. You see, if you switch off some loads, or you switch off the TV or a fridge, the sound will move off, and that sound is used, this alarm sound is used to protect an inverter against overload. Signs you will tell that an inverter is overloaded: alarm sound, that is number one sign. Sign 2, we have seen that an inverter will shut down. Okay, inverter shuts down. Once you load, you have a 300 watt inverter, and you put your total load after wiring your total load, and the total load is 500. The moment you switch on the inverter, it will switch off. It switch on, the inverter will switch off, because it is seeing or it is sensing an overload. Okay, inverter shuts down, switching off itself because of overload. Alarm sounds, and these are the signs which shows that the inverter, there is an overload over a inverter, meaning you are putting an inverter a big wattage, whereby an inverter can't drive that wattage. Okay, and let us see the causes. What causes this? What causes the inverter overload? I'm giving you number one cause which causes the inverter overload. Okay, too many appliances connected. Too many appliances connected on an inverter. This I have explained here. Too many appliances, meaning appliances, when they say too many appliances, we calculate them in wattage. As I told you, we have, this is the total appliances. We have 500. the inverter is 300. Meaning the total watt of an appliance, there are many than the driving inverter. The inverter needs, if it is 300, it needs a wattage below 300, not above. Once it is above 300, it is overload. And here comes the cause, because you have overloaded the inverter. Too many appliances connected to an inverter, and that is the cause. Meaning reduce on an inverter, or calculate the inverter which is capable of driving your total load or total wattage of the appliances. Okay, now let us see the solution. How can we solve this problem of overloading the inverter? Let us solve this problem, how to overload, to reduce the inverter overload. Now we are going to see the solution. How can we solve this problem of the inverter overloading? How can we tackle this problem? Let us tackle it with no wasting time. The solution to solve inverter overload. One solution I have given is reduce the loads. Reduce on the loads which you have put on an inverter. Either you have put a lot of lights or bulbs, TVs, fridges. Please reduce on the loads. Either remove the fridge from the inverter and let the inverter work on the light and the TV, or remove some bulbs. Okay, reduce on the loads, and the inverter will normalize its running or its operation. Okay, another solution I've given is upgrade the inverter capacity. Upgrade the inverter capacity if necessary. Upgrade the capacity, I mean, if our inverter was 5, if our load, the total load, okay, let us say if our total load was 500 watts, the total load of the appliances, the wattage of the appliances, all the appliances, and our inverter was 450 watts. This is an inverter. This is the total appliances. Okay, you see that the total load is 500, and yet you want your appliances to work all. Okay, but you have an inverter of 450. Upgrade the inverter capacity. Upgrade the inverter capacity, they mean, if possible, if you want all your appliances to work, upgrade this inverter capacity. Meaning, buy something like an inverter of 800 watts, or 900 watts, or 1000 watts, which is 1 kilowatt. After upgrading your inverter, all your appliances will work properly. That's why I've given you one of the solutions is upgrade the inverter capacity if necessary. If there is some money, buy another inverter with higher capacity. Higher capacity, I mean higher watts, to drive your appliances and reduce some loads. If you don't have this option of upgrading the inverter, please reduce the loads and the inverter will normalize on its operation. Let us see the last solution. I promised to give you 3. I've given you 1, which was the inverter not turning on. 2, the inverter overload. The inverter is overloaded and we see the solution. 3, let us see the number 3, which I've promised to give you. You see, the way I explain the solutions, please get note that this solution will help you to solve the problems of these solar components. Okay, once you know the functions of each component, it gives you a way forward to solve all the problems. Let us see the problem number 3. Now we are seeing the third problem, which is facing the inverters. Okay, the solar inverters. I'm giving you 3 problems. We are on the third problem, which is overheating. The problem of overheating. An inverter getting heat. It heats up. Why does an inverter heats up? How can you tell that an inverter is heating up? Let me give you the signs. Overheating is a problem in an inverters. The transformer can heat up. Electronic gadgets can heat up, and making an inverter to heat up. But how can you tell that an inverter is heating up? Without you noticing, like without you using your naked eyes. Sign number 1, cooling fan. They are inside fans. The cooling fan running constantly. Some inverters have fans inside. The use of the fan is to cool the inverter when it is heating. Now, when you see these inverters, this fan running constantly, these fans will run constantly, meaning the inverter is heating up and these fans are trying to cool the inverter. And that is one of the indication, the sign which shows that an inverter is heating up. Okay? Our problem, overheating. Okay? Now, another sign which you can tell that an inverter is heating up, the inverter will shut down during operation. Once the heat come continuously and the fans are trying to run to run constantly, the inverter, once the heat, there is a fan and there is inside an inverter, there is heat sinks. Those copper heat sinks, not copper, I mean aluminum heat sinks, okay, which take out the heat from the electronic components. If the fan also tries its best and the heat continuously comes, the inverter will definitely shut down, and it will tell you that after you come near the inverter to switch it on, you will feel the inverter when it is really overheated. And these are the signs. Cooling fan running constantly, it indicates that the inverter is heating, it is not stopping the heating. Shuts down during operation. Once the inverter shuts down during the operation, it means it has experienced the heat, too much heat, which makes those electronic components to shut down, to switch off the inverter automatic. Okay? Now, let us see the solutions. Solutions how we can tackle the overheating of an inverter. Okay? Technically, one of the solutions is improve air flow. Improve air flow. Check your inverter. Don't cover the inverter. Okay? The inverter has holes at its sides. These holes, this way, it is for air to pass through, in and out. Okay? So that the inverter can cool. If you see that your inverter is overheating, please try to modify the housing of an inverter so that it improves on the air flow. That's one of the solutions to prevent overheating. Another solution is remove dust. Remove dust from the inverter. Open up an inverter, get a blower which blows air in high pressure. Blow in the inverter. This dust causes the components in the inverter or the transformers in the inverter to generate heat. Okay? Because these components, if they are clean, they are free to dissipate heat away from them. Now when the dust is on them, the dust covers these components with heat, and the heat is nowhere flow out, which leads to an inverter overheating. Remove the dust. That's another solution. We said one solution is to improve air flow by improving the air flow, the gaps where the air can pass. Another solution was remove the dust. Okay? Solution number 3 is reduce the loads. Okay? Reduce the loads. Reduce on the loads on the inverter. The inverter may be, your total load may be 500 watts. That's the total appliances loads. And again, you put an inverter of 500 watts. You see, our inverter, this is the total load for appliances. This is an inverter. 500 watt for the total load and 500 watt for the inverter. Meaning an inverter has no breathing space. There is no breathing space for the inverter. The inverter is driving the total load which is equals to the inverter wattage. No breathing space, like no wattage, no free wattage for breathing. Meaning the transformer inside the inverter is trying hard to generate that power which is needed for your loads to run. Meaning the inverter, the total load, this side the total load, and this side is 500, this side is 500. Meaning no space for breathing, and this makes an inverter to heat up. Heating up, it means the transformer which is stepping up the total power which you need by your loads is equals to its power, okay, whereby it has no, the transformer has no breathing space, and it will heat up on its lamination or its turns, leading to high or overheating of an inverter. And once you reduce on the loads, let us say you have reduced your loads to 300 watts, okay, now the inverter is 500 watts. There the inverter will try to reduce on the heating because it has a breathing space of 200 wattage, and the heating will reduce. And these are the solutions which I can give you technically as a solar technician, okay, or electrician who has installed solar system. Thank you for watching today, and if you find this video so useful, please subscribe, like, and share, or comment in the comment section for any problem. If you have any problem in solar system, please comment and I will see how we handle the problem together. Share this video to your family members, to your friends who have solar system, who want to improve or who are facing some problems with their solar inverters, okay? I know we are going to look at the inverter in coming days, how to make an inverter, inside the inverter, how to do the repair of an inverter, everything. We're going to see also some projects in solar system, like this project in farms. If you have a farm, you may need to have this solar knowledge, solar water pump in your farm, like in African countries, whereby they wait for seasons, rainy season and dry season for their crops. They wait for rainy season. But once you have a solar system, you can buy a water pump which works on DC or on a solar, or you have an inverter. You can also install an inverter, and this solar can pump water from down, then it irrigates your farm, okay? Thereby you will not wait for rainy seasons. It means for you every day it's a rainy season. We shall look at this project, and also there is a project of solar cooker, okay? How can we make a solar cooker, cooking on solar to save deforestation, to save that deforestation, okay? There are many projects in solar. We shall look at them. Don't worry, just like and subscribe. See you in the next video about the wiring, the problems in wiring, okay? Some technicians have problems in wiring, how you can size your cables, how you can wire your solar system. See you in the next video about the problems in wiring and their solutions. Thank you for watching.